Hello everyone, I am Dr. Aliashim Albani from Universiti, Malaysia, Terengganu. Today I would like to present our research entitled Ocean Current Energy Potential at Selected Sites in Malaysia. So here is the outline for my presentation. So here is the abstract. This paper aims to present the ocean current power density data at 4 selected sites in Malaysia's seawater. The sites are 2 points in southeast part of Sabah and 2 points in the southeast part of peninsular Malaysia seawater. The data were obtained from the Copernicus Marine Environment Monitoring Service (CMEMS) Center Numerical Model Product. The obtained variables were northward and eastward components, where the ocean current speed, direction, and power density were generated using the specific equation directly. So here the site 1, which is located at 14 km from the Lahadatu northeast. Here is the site 2, which is located at 26 km from Sandakan southeast. Here is the site 3, which is located at 9 km from the Dungun northeast, and site 4, which is located at 112 km from the Pekan southeast in Pahang. So two variables, northward and eastward components, were obtained from the numerical model product available from the CMEMS center. Okay, here the link. Yeah. Okay, the CMEMS database has been widely used by several researchers to evaluate wave and tidal energies. Okay, but this simulation has some weakness in terms of accurately representing some storm event, but in generally represent mean value quite well, and this database purposely um, uh, homogeneous long-term data and higher spatial coverage than that achieved with a single point observation. Okay, so data were processed and extract to the spreadsheet using the ArcGIS, okay, NetCDF feature toolbox. Okay, this kind of data also utilized by Shadman in 2019 to study the ocean renewable energy potential in Brazil and also in other different region, yeah, which is uh, studied by the ROC in 2016, Nacheni, okay, and in 2012, 2017 and 2018. So for the speed and direction, okay, we calculate using this equation. Okay, so the eastward component, northward component, and then we can compute the ocean current speed using this equation. Also the degree of direction using this equation. So for current power density, we calculate using the following equation, where P is the current power density with a unit watt per meter square. Here is the sea water density, which is we define 1035 kilogram per meter cubic, and V is the current wind speed, yeah, or velocity. Okay, for result and discussion, okay, the table 2 show the annual average of ocean speed data for site 1, site 2, site 3, and site 4. Okay, we can see for the annual average, okay, the highest annual average current speed is in site 4 with 0.54 meter per second, followed by site 2 0.50 meter per second, and site 1 0.23 meter per second. Okay, the lowest average current speed is in site 3, yeah, with 0.13 meter per second. Okay, the prominent current direction for all sites is the northwest okay, direction in a range between 276 degree to 347 degree. So here the map produced in GIS using the ArcGIS NetCDF feature toolbox. Okay, during the northeast monsoon, okay, the map is during the northeast monsoon that occur from November to March. Okay, and we can see this region, the red color show the most potential site with current speed more than 1.5 meter per second. Okay, so the 1.5 meter per second is the significant value to operate the uh, current energy converter. Yeah, so the bluer side showed the calm area, okay, calm area, and considered no potential or less potential for energy development. So here the map of during the southwest monsoon that occur from May to September. Okay, we can see that only few sites, okay, a few sites show the potential, and mostly, okay, mostly the region show no or low potential in energy current converter. Yeah. So figure 4 diurnal average for current speed and power density. Okay, it show the no significant difference actually during day and night in terms of current speed trend. Yeah, so there are only few deviation from its average value. Okay, however, that data for year 2018 showed the quite far from its average value. Maybe there are some error, yeah, during on the CMEM's data, that should be not. Yeah. So for figure 5, monthly average for current speed and power density. Okay, for site 1, okay, and site 2 that located in Sabah, it is clear that the current speed is higher during the northeast monsoon. Yeah, northeast monsoon from the November to March. Yeah. However, for the site 3, okay, that located in Peninsular Malaysia, water, yeah, the current speed is higher during the southwest monsoon. Also, the highest current speed recorded in site 4 during July, which is the value is 1.04 meter per second, followed by site 2, okay, in the November, yeah, 0.86 meter per second. Okay, for conclusion, yeah, this work is based on the preliminary statistical evaluation, yeah, for the current velocity, current speed, characteristic, and power density at four selected sites in Malaysia. Okay, the objective of for this research actually to evaluate the potential of marine current, preliminary evaluation for the potential of marine current in Malaysia, and to identify the most suitable site for the development of current energy. Yeah, in general, the region in Malaysia also recording data with more than 1.5 meter per second, but on average, most sites show less than 1.0 meter per second. Okay, as I mentioned before, the 1.5 meter per second is a significant value to operate the current energy converter. Yeah. There are more studies are needed to determine the potential, including the use of measured data, yeah, instead of a reanalysis data. Okay, the Siemens data is the reanalysis data. Okay, the development of current energy converter for application in Malaysia also should be consider the condition of Malaysia current speed, which is below than 1.5 meter per second. So here is the reference, okay, for this slide. Okay, thank you.